There are many ways to prove that a quadrilateral is a parallelogram. The first way is to use the definition of a parallelogram. If we can show in our quadrilateral that we have one pair and two pairs of parallel sides, then by definition we have a parallelogram. Another way to show that a quadrilateral is a parallelogram: if we can prove that our opposite sides are congruent. If we have one pair and then two pair of opposite sides congruent, then by theorem 6.7 our quadrilateral is a parallelogram. If in our quadrilateral we can prove that our opposite angles are congruent, if we have one pair of opposite angles congruent and a second pair of opposite angles congruent, then we have a parallelogram by theorem 6.8. Theorem 6.9 says that if we have a quadrilateral and in that quadrilateral an angle is supplementary to both consecutive angles, then the quadrilateral is a parallelogram. It sounds confusing, but if we say, here's the angle that I'm talking about, I'm going to call it angle 2. And that angle 2 is supplementary to both consecutive angles. Well, this is a consecutive angle, angle 1, and this is a consecutive angle, angle 3. If the measure of angle 2 plus the first consecutive angle, angle 1, equals 180 degrees, these two angles are supplementary, they're consecutive interior angles that are supplementary, I know that these two lines will be parallel, and angle 2 is also supplementary to angle 3, the other consecutive angle. Well, that means that these two consecutive interior angles make these two lines parallel. Then by theorem 6.9 we have a parallelogram. Theorem 6.10 uses the diagonals of a parallelogram. If our quadrilateral has diagonals that bisect each other, then by theorem 6.10 that quadrilateral is a parallelogram. And the last way to prove that a quadrilateral is a parallelogram: if our quadrilateral has one pair of opposite sides congruent and one pair of opposite sides parallel, then by theorem 6.11 we have a parallelogram. Let's look at some of these theorems. Decide which theorem would be used to prove WXYZ is a parallelogram. In our first example, segment WX is congruent to segment YZ, and segment XY is congruent to segment ZW. Well, which one of these pictures does this look like? Looks like theorem 6.7. I have two pair of opposite sides congruent. two pair of opposite sides congruent. I would use theorem 6.7 to prove that this is a parallelogram. I'm going to erase these tick marks for problem number 2. In problem number 2, segment WO is congruent to segment OY, and segment XO is congruent to segment OZ. So which one of these pictures does this diagram look like? It looks like theorem 6.10. If we look at our picture, this tells me that O is the midpoint of WY, and this tells me that O is the midpoint of XZ. So O is the midpoint of both diagonals. Both diagonals bisect each other. So by theorem 6.10, we have a parallelogram. I'm going to erase those tick marks for problem number 3. Angle ZWX, Z to W to X, is this angle right here, is congruent to angle ZYX, Z to Y to X, that's this angle. WZY, angle WZY, WZY, is congruent to angle WXY, WXY. So which picture does this diagram look like? Looks like theorem 6.8. If I look at what I'm given in problem number 3, this tells me that my opposite angles are congruent. So I would use theorem 6.8 to show that this is a parallelogram. Erase those tick marks. Number 4 says segment WX is parallel to segment ZY. And segment WX is congruent to segment ZY. Well, that one looks like theorem 6.11. I have one pair of sides that are opposite, congruent, and parallel. So I would use theorem 6.11 to prove that I have a parallelogram. And the last problem. Angle ZWX, Z to W to X, plus angle WXY, WXY, are supplementary. They add to 180 degrees. And angle ZWX is congruent to angle ZYX. ZWX is this angle. ZYX, Z to Y to X, is this angle. So I have one pair of opposite angles congruent, and these two angles are supplementary. I think I'm going to use theorem 6.9, but I can't quite yet. Before I can use theorem 6.9, I need to take this statement and substitute right here to create this statement. The measure of angle ZYX plus the measure of angle WXY equals 180 degrees. Now if I look, if I call this angle WXY angle 2, angle 2 is going to be supplementary to the two consecutive angles. Well, here's the first consecutive angle, angle 1. Let's just call that angle 1. And my other consecutive angle, I'm going to call that angle 3. So I have an angle that is supplementary to the two consecutive angles. by theorem 6.9, I have a parallelogram.